welcome back to another video on my YouTube channel. And in this one, we're going to solve the elevator challenge. So let's jump right in. This elevator won't let you reach the top of your building. So what we need to do, we have a boolean that is set to false at first. Its initial value of every boolean that doesn't have an initial value is false. So we need to change this to true somehow. And let me say, just clarify what this level will teach us. So this is the game to show the importance of interfaces and composability in the Ethereum and Web3 ecosystem, and how by using interfaces incorrectly and not using modifiers correctly, you can introduce security flaws in your contract. What does composability mean? It means, well, when building your smart contract, you can use other smart contract instead of reinventing the wheel and building features from scratch, because contracts once feature has been deployed, you can just use and interact with that contract. You don't need to build it yourself, which also saves on space into your contract. You probably know that you cannot really put on the blockchain. There's a size limit, contract size limit, to which you can put on the blockchain. So to kick things off, get a new instance, go into the console and say contract.address. We'll need this address of this contract to interact with this contract and exploit it. So we have an interface called building with one function is that floor that is external. So interface can only have external functions. It returns boolean and it takes in a uint as an argument. We have a contract elevator that has top boolean value, floor uint, and simple go-to function. So it's very obvious that the bug lies into this go-to function, especially if you see that we modify the top value here. Somehow now we need to make this output to be true, and if we make top to be true, it means we've passed the level. We need to bypass this if check, and that's pretty much it. So I've pasted the level code here. It's very simple to solve this challenge, and let's first hack the contract, then I'll show you the how to prevent this security flaw and how to fix the bug. So if we see here, we pass in this floor as an argument. We use this floor to pass into this function, and to pass this if check, what we need to do, how can we pass this? This needs to return false, because exclamation mark means opposite of the false, which is true. So we pass this check, and then somehow this floor here, this is different from the argument, is put into this call, and that needs to return true. And how can we do this? Well, the first thing I thought is, so basically the first time you call this function needs to return false, so we can pass the check. And the second time we call this function, we need to return true. And that's basically it. You can even skip this. And that's what I've done and how I've solved the challenge. So what I'm doing here in my attacker contract, we'll use an attacker contract. And I forgot to mention, but it's important to note that here we are saying, hey, use my address, the color of this contract address, to convert it and treat it as a building. So this can be either an EOA or a contract. It can't be a EOA because it has functionality, it has functions. It's treated as building. So we have to create, that's how we know we have to create a contract. So here I pass in the elevator address contract because I want to call its go-to function to exploit it. And I have my isLastFloor function. So my address of this contract is treated as building. So we have to implement this isLastFloor. And it has to be implemented in a way that it returns, first of all, it returns false to pass this check, and then true to solve the level finally. Very easy. So what I've done is a very simple solution. I have a count variable that tracks the amount of times this function has been called, If it's 0, I'll just return false because it's the first time, and I'll increase this to 1. Then if it's not 0, it means it has been called before once, and then we just increment to 1. We don't really even have to, and I'll just return true. So that's basically it. So the first time this function will return false, and the second time it will return true, and that is exactly what we need to solve this goto function or hack the level. So for the beginners out there, I don't have to show you this because it's pretty simple, but let's deploy the elevator contract and then choose the attack elevator, copy the elevator contract address, paste it here into the constructor, and deploy the attacker elevator contract. So you can see the top in the elevator is initially set to false. But what happens if I delete this and call the attack contract? Transaction is successful, and now top is set to true, which means we have passed the level. And I'm doing all this in the remix blockchain, but of course you need to interact with the elevator contract that is deployed here with this address on Gurley. That's deployed on Gurley with this address. So that's everything you need to change, and you've pretty much solved the level. And also, I want to give shout out to this guy. He's helping me to whenever I do these kind of videos. I also watch him, so he's been very helpful. And lastly, I'll put this link down below, and I'll add all of the Ethernaut levels and how I've solved them in this repository. So if you want to copy the code, you can do that here for all the levels.